Okay, so we are starting section 4.3, literal equations. These may be something that you haven't heard of before, so I figured that it would be best to probably start with the definition, okay? A literal equation is an equation in which the coefficients and constants have been replaced with letters. In other words, you don't have any numbers in your equation. It's just variables. And that's, something that you're going to have to get used to as you get into your upper level math and science courses. Now, we're going to deal with literal equations in two different ways. We're going to deal with them in a way of which you're going to take an equation and solve for a certain variable. So you're going to move things around. So there's going to be more than one variable in the problem, and they're going to say solve for B, solve for C. And then you're going to take that equation and make it fit to solve to be equal to that certain variable. And then we're going to see some of these equations where there's no numbers in them, and you have to still solve for a certain letter, but there won't be any numbers involved. So the first question that you may have, maybe, I'm just assuming, is why would you need to know about literal equations? Well, the first reason is you have to use it to graph equations. Needed to graph equations. And that's what we're going to do in the next unit, is we're going to be graphing linear equations. But before you can do that, you've got to get the equation ready to be graphed. And the way that we're going to do that is how I'm going to show you in a few minutes with the first couple of examples. Okay? So that's the first reason you need to know how to handle literal equations. And then the second reason is just like I mentioned. You're going to need it. You're going to need it in geometry for sure, where a lot of the information that you're going to learn in geometry is dealing with formulas. You're going to have to know formulas, and in these formulas, the letters are going to represent numerical values. So you've got to know that if I need the volume of a cylinder or the height of a cylinder, how to take that formula and be able to do both. Literal equations. So you're going to need it in geometry. I know you're going to need it in chemistry. Some of you guys will take chemistry and physics in the next couple of years. So this is something that you have to be familiar with, and then it's really going to kick in, as you go on into your other classes in high school. So it says, the next sentence, when an equation has two variables, okay, so we're talking about more than one, the equation must be rewritten so that one variable is a function of the other. So this is what you put in that blank on your notes. One of the variables is a function of the other. That's just a fancy way of saying one variable needs to be equal to everything else in the equation. You're going to isolate that variable just like we've been doing our x, but instead of x equal to a number, x is going to equal to everything else from the equation. Everything else will be on the other side of the equal sign. Okay? So if you've gotten all this written down, I'm going to erase it, and I want us to try one of the example problems. I'm going to erase this. Okay? So let's look at example 1. Okay? And they're always going to tell you what variable to write the equation as, okay? Write 3x plus 2y equals 8 so that y is a function of x. So in other words, you're going to solve for y. I know that's some fancy talk right there, but what they're really saying is if you want y to be a function of x, they just want you to solve for y. So that means you got everything going on here. It all needs to be moved over so that your final answer is just y equal to everything else. Okay? So let's look and see what's going on. Because remember, I want you to stop and take a minute and look at the equation before you jump in and start moving things and canceling and all that kind of stuff. So in this case, 2 is being multiplied to the y, and 3x is being added to it. Okay? Now, I don't need you to touch that x. I know that we're used to the x being the answer, but not when you're dealing with literal equations, unless they tell you to. So I need the whole 3x to stay together. These two are partners. They're not going to separate because my objective is to get the y by itself. So I need to move the 3x over. And the way that I'm going to do that is to take the inverse. The 3x's cancel. I'm left with 2y is equal to, now watch me, how many of you can tell me what type of terms 8 and negative 3x are? Are they like terms or unlike terms? I'll give you like 2 seconds. They're unlike terms because of this x. So you cannot write 5x, ladies and gentlemen. That's not correct. You cannot subtract and add unlike terms. So this right-hand side is just going to be those two terms. You see what I'm saying? You can't do anything with it. Okay? Now, the y still has this 2 right beside it. So I need to take this 2, if I'm multiplying the 2, and divide it by everything. So that means that both of these terms are going to get divided by 2. So I know that I have to divide by 2 here, so they cancel out. And then the 8 has to be divided by 2. And then the negative, you notice how I said negative? The negative 3x is also being divided by 2. The 2's cancel out. My y is by itself. 8 divided by 2 is 4. Okay? Now this x is a variable, so you're really just dealing with the negative 3 and the 2. Well, I know that a negative divided by a positive is always going to be a negative, so I know my sign is going to stay negative. And at this point, you can keep it as 3 over 2, or you can write it as 1.2. I'm going to leave it as 3 over 2x, and then here is your equation. You went from an equation with both variables together to just isolating it, okay? So I'm going to stop the tape, and then we're going to try to do the other 2 examples of the same type of problem.